find the slope. So for number 1, the slope is just that number right there in front of the x, your rate of change. So it's just -2. Do not do this. Everybody look at that screen. I've seen that so many times in the years that I've taught algebra. People say, what's the slope? And they write the number and the x. That x is not part of the slope, okay? It's just the rate of change. So don't write that x there and then, not get full credit. Okay, and just tell me if you need me to slow down or whatever, because I'm going to be going through this fairly quickly. Okay, for number 2, I'm just going to make myself a slope triangle, connecting those 2 coordinates. So my rise is 1, my run is 3. We know it goes rise over run. And then you need to decide whether it's a negative slope or a positive slope. This is a negative slope because remember, you read it from left to right. If you got somebody sitting right here on the left-hand side, they are clearly getting ready to slide downwards. So this is going to be a negative 1/3 for the slope. Number 3, remember another word for slope is also rate of change, which is probably more applicable when you're looking at a table. So we need to find our change in our y values. So in this case, from 5 to 7 is an increase of 2. We're assuming on the test these are all linear, which means it does have a constant rate of change. So you don't need to worry about checking any other numbers. You can just do the first 2 on the table. So if my change in y is 2, then I also need to do my change in x, which is 3. So the slope is 2/3. And don't forget, so far I haven't given you any examples where you need to simplify, but if you don't simplify, if you have to on the real thing, that won't be full credit. So please make sure you simplify. Yeah. Right. Yeah. Number 4 is that according to the rubric, so all the ones that are level 2 questions right here, I can identify the slope from a table, function notation or 2 points. You only have to get 2 out of the 3 right to get full credit. So if you don't quite understand number 4, it's not the end of the world. It's because function notation can be a little dicey. But so way back when we did function notation, remember the number inside of the parentheses is your x. So that means that the other number is your y. So this is really just another way of writing an ordered pair by using function notation instead. So you're still going to do your slope formula of y2 minus y1 over x2 minus x1. It just looks a little bit different. So 17 take away 12 will get you 5 for your change in your y values. And then 5 minus 2 will get you your 3 for your change in your x values. I kind of messed up on the study guide by not giving you any that need to be simplified, but on the test, there most definitely could be some you need to simplify. So,
you have to simplify. You have to simplify.
Oh, you do? Oh, good. Okay, cool. All right. So if number 4 didn't make a ton of sense to you, again, it's not the end of the world because you don't necessarily have to get that one right on the test to get 100 for this section. Okay, number 5, once again, this is just a straight up y2 minus y1 over x2 minus x1. So 25 minus 40 for my numerator. And then 5 minus 20 for the denominator. So that gives me negative 15 over negative 15. Oh yeah, so this one we do need to simplify. Negative divided by a negative is going to give you a positive 1 for the simplified slope. If you say 1 over 1, that's fine, like if you want to do that. But technically, because you are technically talking about slope, which is a rise and a run. But it would be better if you simplify it to the whole number. Okay, so those are, if you understood all of those, you have a 75 on this section of the test so far. Anybody got any questions before I swipe to the next page?
Yeah. Why do we do it with the...
You 2 different, oh, yes, darling, I'm sorry. That should say mile. I already changed it on the new copy. I just haven't changed it on this one. Thank you for reminding me, though, because Lord knows I need all the reminders I can get. Okay, so you're going to have a question either like this one or this one on your, depending on which version of the test you get. There won't be 2 questions in section 3, but I wanted to give you 2 different versions on the study guide so that you know, kind of what you're going to get. So the rate of change for Kadisha is is going to be that 3 right there in front of the X. If you want to put, we're talking about money, so you could put a dollar sign on there if you want to, but you don't necessarily have to. I'm not going to be that petty. And then for this one, I would just I would use my slope formula. I would use my change in my Y's. So 131 minus 6, that's a difference of 125 if I subtracted right. But y'all know you need to check me on that. 10 minus 0 is going to give you 10. So you could express this slope in a couple of different ways that would be acceptable. If you just want to do 125 divided by 10 and get 12.5, that's fine. Or if you want to just divide the numerator and the denominator by 5 and leave it as a simplified fraction, you could do that too. What is that? Which one? What is it?
I believe 25.
You're right. Thank you. That is what it was. So either way, you could leave it as just the decimal form or a simplified fraction. I would take either one for that. Okay, so if you understand how to do those two, you're up to an 85 on the slope section. Any questions before I flip to the level 4? All right, we're still finding slope, except now we're comparing two slopes. And so in the first one, it says this equation represents the number of miles that explorer B can fly. Well, how many miles can they fly in X hours? Well, their rate of change is right there. It's 7,800. That means every hour it goes another 7,800 miles. And then for Explorer B, we're going to need to use that rate of change formula again. So from 4,000 to 2,000, that's going to be a difference, of course, of 2,000. And then from 10 to 5, 10 minus 5 is going to be 5. So we've got 2,000 divided by 5, which is 400. But am I finished with that question? No, because it asked me how much faster. So on the real thing, don't do all this work and get the right slopes and don't do the subtraction and not end up getting all of your points. So you've got 7,800. Oh, that was ugly. Sorry. 7,800 minus 400. So your actual answer is 7,400 because it asks how much faster. Okay, so any questions about that one? Last one for comparing slopes. First it says Alexander uses 2 gallons of gas to drive 75.6 miles. So his is in writing. So I'm going to look down here and see that the problem tells me that miles is my Y value. So that means that, your Y goes on top when you're doing slope, right? So that means that 75.6 goes in the numerator, for me to figure out his rate of change. And then the 2 is going to go in the denominator because 2 gallons is my X. So 75.6 divided by 2, what does that give me? 38.3? No, that's not right. 38.8? Did I do that right? Somebody got a calculator real quick. Help me out.
Give me 76.
37.8. That's why it was bugging me. I knew I was wrong, but I was like, how am I wrong? All right, 37.8. Thank you. Okay, and then to find our rate of change for our table, I'm just going to do my change in my Y. So the difference from 266 to 342 is going to be 76, right? And then my change in my Y here, or change in X is 2. So if we do for the rate of change from the table, 76 divided by 2, that gets me 38. So it says how many miles less? Well, not too many. 38 minus 37.8 is just 0.2. So that one had a very small difference in their rates of change. Okay, so if you understood how to do those, basically you got to do a lot of Y2 minus Y1. Basically, you got to do a lot of change in Y over change in X. Remember how to do a slope triangle? Got all that? You've got 100 on the slope section. And same thing on this page. You'll only get one problem like this. You won't get two because I'm not trying to kill you with double, but I just wanted to give you two different examples that you might see. Okay. Anybody not okay if I go ahead and go to the next section?
Yeah. I don't think I'm done with it.
Okay, you're not done with it? Okay.
Yes, I am. Never mind.
You are done? Okay. Okay, that's not what this one is. If it were like y equals 4, remember that one would be a horizontal line that goes through the y at 4. It doesn't have an x in it because the slope is 0, so that's why it's flat. Now, obviously, that's not what we gave you, though, right? We gave you x equals 4, but you should be prepared for either a horizontal or a vertical line on the real thing. So in this case, we've got x equals 4. So you're going to go to the x-axis to the 4, and you're going to give yourself a nice little horizontal line right through there. I'm going to be a little bit petty about arrows and stuff, guys, so please make sure that you're extending your lines, that you're using a ruler, all that jazz to make sure that it's appropriate. Next year, you're going to miss out on all you do. You stay graphing shapes. So if you kind of slack off and don't, you're going to miss out on a lot of correct answers, from your formatting. Okay, number 2 is in slope-intercept form. So we've got our 6. Right here. So we've got our 6 for our beginning point. Now the reason this one is tricky, even if you think you know what you're doing, it can't hurt you to hear this. Okay, you're probably going to have one like this, where it would be easier if you could just go up 3 because the slope is a positive 3. But you don't have room to go up 3, right? You have no choice but to go down. So if the slope is positive, but you have no choice but to go down 3, what direction do you have to make sure you go in as far as left to right? You've got to go left, because if you go to the right, that's positive. A negative and a positive do not make a positive. So you have no choice but to go down for this 3. I'm just going to be so sad because I know a couple of you guys know what you're doing, but you're going to make this little mistake. So please take this to heart. Write yourself a note, something. So if you got to go down 3, make sure you go to the left 1, because those 2 negatives will give you a positive. And then how many coordinates do you need? We need 3. Provided that you have room on the graph for that. Go all the way across the graph and add your arrows. Okay, so any questions about number 2? All right, number 3. You could technically switch this over into slope-intercept form if you wanted to. The issue with that is because of that 1/2, it's going to give you a y-intercept that's abdecimal. So unless you're like Bean, who managed to make it like perfect, like it was actually very impressive, if you're not a great estimator, I would leave this in point slope form and use that. So what do I mean by the fact that this is in point slope form? So remember, this is what point slope form is. Y is my x, so extra. So the x coordinate embedded inside of that equation is a -1. And because the formula involves subtraction, that means that that 1 must have been a positive 1 before you put it into the equation, because it's x minus x1. So it must have been a positive 1 in order to be a negative once you put it into the equation. For the y, since it's a positive number in the equation, that means it must have been a negative to start. So 1, -3 is your first coordinate that is given to you in that equation. So use that point. I gave you a whole worksheet with an answer key. You could practice doing this. I know for a lot of people, point slope graphing tends to be their weak spot. So the slope, of course, is -1/2. So I'm just going to go down 1/2, down 1/2 again. And of course, as always, I'm going to connect it with arrows. So I personally would just retrieve the coordinate that is in that equation instead of trying to switch it over and graphing it. But, I mean, it's your call. As long as you get it right, it doesn't matter to me. Okay, anybody not okay if I go over to 4? You need me to wait a second? The reason I would graph this one by intercepts is because 2 and 5 go into 10 really easily. So to find my y-intercept, remember what you would do is put a 0 in for x, so that would cancel that out and leave you with 5y equals 10. A lot of you guys could just do this in your head probably. So my y-coordinate is 2. Then I need to repeat that process. And again, a lot of you guys probably don't even need to write this part down. Put a 0 in for y, which that will cancel, and leave me with 2x equals 10, which means my x-intercept is 5. When you graph by intercepts, you only have to make 2 coordinates. So I don't know if that's a motivation for anybody or not, but I will definitely, the one that I give you like this in standard form will be really easy to do by intercepts, just like that. But I know a lot of us just like to constantly switch it over into slope-intercept form. Nothing wrong with that. So I'm going to go ahead and do that really quickly too. So you do minus 2x on both sides. That leaves you with a 5y equals negative 2x plus 10. Divide everything by 5. Y is equal to negative 2, oh, not 3, negative 2/5 x plus 2. So look, y-intercept of 2, still that same beginning point. And if I use that slope and go down 2 and over 5, either way, you end up with the exact same line. It's just your choice about how you prefer to get there. Okay, so if you understood how to do all of this, you've got a B on the graphing section. You got an 85. Anybody not okay if I show you the level 4 questions now? Okay. I love the enthusiasm. Okay, first of all, on the real test, hand to God, I am going to figure out a way to make our piece of garbage copy machines actually show the graph. I don't know how I'm going to do that, but I will do that. So for the first couple of, and you're only going to have one question like this on the test, but I gave you 2, so you could see an example of every possible way it might be asked. So Raymond, my hubby, decided that there was a linear relationship apparently between his homework and his quiz scores. So if he does no homework, he can expect to get about what? A 60, right? If we go to no homework and go up to the y-intercept, he could expect to get about a 60. That one you can tell by just looking at it. The other two, you really need to get the equation of the line. Now, there are some people that are just super good at eyeballing it, right? So it might say he can expect to get about 100, which you know is going to be around here-ish. Some people can like visualize the line. I'm going to tell you right now, I am not one of those people. I personally would just get the equation of the line. And since it does give me like, there's like a coordinate right here where it hits in a corner, I would use that to get the rate of change. And let me show you what I mean by that. So my change in my y values, so 86 minus 60 over my change in my x values, that would be 4 minus 0. So this gives you 26 over 4, which gives you 6.5 for the rate of change. So the equation of the line would be y equals 6.5x, and then you know that y-intercept is 60. So how does this help me to answer the second question? Well, because now I can take that equation line, kind of like you did for your project, and if I want to know how many hours he needs to study to get 100, I would just put 100 in for y and solve it. So subtract 60 from both sides. This will give you more of a precise answer. And then, oh, what did that end up being? 6 point, is it 6.2?
It's like 6.1.
Or it might be 6.3. Hold on. It's like 6 point,
It was 6.1.
what,
It was
6.2? Okay, all right.
On the test, would we have to like exactly get that?
Okay, so Sophie asked an excellent question. Okay, first of all, what does the question say? It says he could expect to get about this score, right? So if you're somebody that's really good at eyeballing it And you don't need to do it exact like I do, because it says about. About means an estimate. You could have something different besides that 6.2. You might have a 6. You might so as long as it's reasonably close. Because some people really can just visualize that estimate by looking at the line. I'm not trying to penalize you for you being better at that than me. Okay? So, any question? Good question, ma'am. Last question. Another reason you probably want to get that rate of change is because the rate of change means every single hour that he studies additionally, that's about how much you could expect his score to go up. So if this is how much it goes up if you study for 1 hour, the way you would figure out what his score would be if he studies for 2 hours or 2.5 hours is you just do 2.5 times that 6.5. And Abby, I know, what would you get once we did that together back there? 16.25, thank you. So I would, if the rate of change, remember what it means. Rate of change just means after every increase of 1. So if it's by 2.5, now if you say 16, that is obviously fine. Honestly, if you say 17, I would probably be okay with that. But finding the rate of change is going to be the easiest route for a problem like this. Do what? Okay, I'll get you in 1 second. Okay, so this one, you pretty much don't need to do a lot of work for this one. There's a lot you can just look at the graph, including the fact that you can see this coordinate pretty easily. So a 4-mile trip, how much would it cost her? It would cost her $16. You can tell that just by looking at the graph. You could expect her to pay, $12 for a trip that is about 2.5 miles. Again, you can tell that one just by looking at the graph. But then I would probably do the rate of change to answer this question. And again, you've got a coordinate that you can use. Because you need to know for every 2 additional miles how much it would be. So the rate of change will tell you how much for every 1, and then you can go from there, right? So if I use those 2 coordinates right here, because that one's 0, 4, and 4, 16. So my change in my y, so 16 minus 4 gets me 12. Change in my x gets me 4 minus 0, which is 4. So that simplifies to 3. So if the rate of change is 3, that means it increases by 3 every 1 mile. So how much would it be for every 2 miles? 6, exactly. So you do 3 times 2, and you get 6. So if that made sense to you guys, you've got yourself 100. Last section for today. So write the equation in slope-intercept form. I literally gave you the slope and the y-intercept. So it's just a matter of writing it down. So y equals negative 5x plus 7. All right, for number 2, this is a real-life situation, but it is still written in just a basic standard form. Since it's, well, not standard, I'm sorry, slope-intercept form. Since it's $4 for each t-shirt that you purchase, that is your rate of change. For every t-shirt you buy, it's going to go up by 4. So it'll be 4x plus the 25 you had to pay. So y equals 4x plus 25. What is point slope form? Okay, the biggest mistake that people make on this part of the test is they don't read the directions about what format they're supposed to have. So don't do it all right and then goof because you didn't read the directions and you know how to do it. So point slope form is y-o-y is my x-o extra. Okay, so this one, and they gave you the slope and the point so that you really don't have to do any work. So instead of y minus y1, it's going to be y minus negative 3, which we all know what happens when you do minus and minus. It's going to turn into a positive. Hey, I appreciate the enthusiasm. Today sucks. I know study guide days really are boring. Okay, instead of the slope, we're going to put in a 1/4. And then x minus x1 is just going to be x minus 2. So don't do this. I see people do this every year when I do this test for Algebra 1, and it breaks my heart. They get this answer, and then they like distribute and move the 3 over to the other side because they forget you're not doing slope-intercept form. So don't do extra work just to get it wrong. Like, please don't do that. I see it every year, and it makes me very, very sad when I'm grading. Okay, number 4. Now, number 4 asks for both point slope form and slope intercept. Well, they didn't give you a slope, so we're going to have to get that ourselves first by doing y2 minus y1 over x2 minus x1. So that's negative 4 over negative 1, which means the slope is 4. So then I need to put that into y, oh, y is my x, so extra, because it asks for point slope form to start. It does not matter which coordinate you choose. The answer will be counted correct whether you use the first coordinate or the second coordinate. Either one is fine. So it'll be, if I use the first one, it'll be y minus 2 equals 4 times x minus 2. Or you could have y plus 2 equals 4 times x minus 1. Either one of those is correct. Then finally, it also asks for slope-intercept form for this one. So we've got to take one of those point slope equations. Again, it doesn't matter which one. You will get the correct answer either way. And we need to distribute, because there's no parentheses in slope-intercept form. And then we need to add 2 to both sides. So we get y equals 4x minus 6. So either of these answers is correct for the first part, but only one answer is correct. No matter which point slope you started out with, you should get y equals 4x minus 6. Okay, any questions about 1 through 4? Okay, you've got yourself a B if you know how to do that on this section. So the level 4 question is going to look like number 5. Bless you. Okay, so it says write the equation of a line in point slope and slope intercept. Okay, so it says it's parallel to this. What do you know about slopes that are parallel? They're the same. Well, before we can figure out what the slope of this line is, we need to get it into slope intercept to figure out what the slope is. So I'm going to do this part pretty quickly because I know you guys know how to do that. So I'm going to move the x over to the other side. Then I'm going to divide by negative 3. I really don't even need to finish this out because all I'm really interested in is that slope right there. So what is that slope? What number is actually in front of the x? There's a negative 1 there. So that's negative 1 over negative 3. Those two negatives are going to cancel out to become a positive. So the slope is positive 1 over 3. So we just did all that work just to get a slope so that now we can put it into that point slope that they ask for part 1. So it'll be y plus 6, because we did minus a negative 6, is equal to that slope we just got times x plus 6. Sorry, that's a little squished in there. Let me scoot this over. Okay, and then now so that's part 1 for the point slope format. Then we still need to get it into slope intercept for the second part of the question. So I am going to distribute, because there's no parentheses in slope intercept form. So 1/3 x plus 2. And then we need to do minus 6 on both sides. So you get y equals 1/3 x minus 4. All right, so that is the entire, oh, yes, dear. Alrighty, so now we're in the next section here, section 4, systems of equations. And so for this one, you're being asked to determine whether or not this coordinate is a solution. And so what you're going to need to do, I'm going to rewrite the first one over here. is you want to take the y value and substitute it in there for y. Then you want to take the x value and substitute it in for x. And then if the equation balances, you know that it's a solution for that equation. So we're going to do -9 equals -18 plus 9. Well, -18 plus 9 is -9, so we know it works for the first equation. But for it to be a solution for the entire system, it's got to work for both. So I'm going to write the second one over here. And I'm going to do the same thing where I am going to substitute the x value for x. I'm going to substitute the y value, for y. So we've got -6 plus 18. Well, -6 plus 18 is equal to 12, so it works for that one. So my answer is going to be yes. Remember, it's got to work for both, though, so make sure you test them both on the real thing. Okay, so for number 2, remember that if the two equations do not have the same slope, that means they're gonna intersect somewhere. We don't necessarily need to figure out where, because that's not what's required for this question. So that'll have one solution because it means they'll intersect somewhere. If it says no solution, okay, if they have no solution, what that's going to be is you're going to have two equations that have the same slope because they're going to be parallel lines that never intersect. And then here's the one where you got to be careful. An infinite number of solutions is going to be the exact same equation. So if you rearrange one of them, like I guess we're going to rearrange this one, and if it ends up being exactly the same, then that means, including the y-intercept, then that means that it would have an infinite number of solutions because it's the same two lines graphed on top of each other. So basically what you're going to need to do is figure out whether or not, after you rearrange this equation, what relationship does it have to that one? And that'll help you figure out which answer. So that's what I'm going to do. So I'm going to take this x minus 2y equals 8, convert it into slope-intercept form. And oops. So then if I divide everything by -2, okay, so I can kind of stop right here because all I really need from this equation is the slope. And so you can see that there's a 1 in front of that x. So the slope is going to be 1/2. And because it's a negative and a negative, it's going to be a positive 1/2. So the slope for this one is 1/2. So what does that mean? Well, this one has a slope of 1/2. That one has 2/5. That means they are not the same slope, which means that your answer should be that this has one solution. For the next one, I'm going to graph the top equation by using my slope-intercept form. So that y-intercept is -4. And then I'm going to use the slope to go up 2 and over 3. I don't have enough room to make 3 coordinates for this one, so that's okay. Make sure you make it go all the way across the graph and add arrows and all that jazz. And then for this one, I'm going to switch it over into slope-intercept form. Or you could do intercepts, either one. But I'm going to do it this way because I know a lot of you guys do it this way. So y equals -1x plus 1. So I'm going to graph my starting point at +1. And then I'm going to apply that slope by going down 1 and over 1, down 1 over 1. And you can see they are going to intersect right about there once I make my line. So remember, do not forget to, after you've gone through all this work, you see your answer is right there. Don't forget to actually list it out. So it should be 3, -2. So make sure you actually say what is the solution, like where do they intersect. Number 4 says solve algebraically. So what I mean by that is you've got to show that you did it either by substitution or elimination. If I don't see work involving one of those two things, then you're not going to get full credit. So please make sure that you pay attention to that for that part of the test. So over here, since the y is isolated and the y is equal to 3x minus 2, I'm going to take this bottom equation and replace the y with, you guessed it, a 3x minus 2. And then I need to distribute. I'm going to bring down the -2x. Since those are on the same side, I'm going to combine them. Oh, snap. I just realized when I distributed, I didn't do the 3 times 2. So that should actually be -6. Sorry about that, guys. So I need to change this also to -6. Okay, so now I'm going to add 6 to both sides. I got 7x is equal to 0. Divide both sides by 7. So my x-coordinate is going to be a 0. So now that I know my x-coordinate, I'm going to use this equation. And I'm going to substitute 0 in for x. So my y-coordinate is going to be a 1. So my solution is 0 and 1. Right up there. Sorry, that took up a lot of space. Sorry, you guys. I do not know what the heck is wrong with me. You guys might have noticed. I knew something was off here. Duh. Okay, let's try this again to get that y-coordinate. Okay, 3 times 0 is 0, and then 0 minus 2 is actually going to give me -2 for that one. My bad, y'all. Okay, for number 5, I think this one's set up very well for elimination. So I am going to multiply the top equation by -2. And the reason I'm going to do that is because that's going to make this front term a -2x so that it'll cancel out with that positive 2x in just a second. But I got to multiply everything by -2. And now I'm going to combine them. So that will cancel. I've got 10y is equal to 20. Divide both sides by 10. Y is equal to 2. So now that I've got my y-coordinate, I need to go back and use one of the original equations to solve for x. So I'm going to take that 2, put it in for y. So x minus 4 equals -4. Add 4 to both sides. My x-coordinate is 0. So my solution for this one is 0, 2. Alrighty, last one for system of equations. So let's see. So I'm going to look at all my things that have to do with money first. So fancy shirts cost 25. Plain shirts cost 15. I'm going to make fancy shirts x and plain shirts y. So it's going to be 25x plus 15y is equal to 185. And then She bought a total of 9, so that means the number of fancy shirts plus the number of plain shirts is equal to 9. So these are set up, in my opinion, pretty well for elimination. So I personally would multiply everything by negative 25. And the reason for that is because then it'll cancel out with that positive 25. So I'm going to rewrite everything over here where I've got a little bit more space. And then here's the new equation after I get done multiplying everything by 25. So those will cancel. This will leave me with negative 10y, negative 40. Divide both sides by negative 10. Y is equal to 4. So now that I know that y is equal to 4, well, actually, I was getting ready to do too much work. Because if they both just add up to 9, then that means that x has to equal 5. So make sure you say something like, label it like fancy shirts and plain shirts, something like that on the real thing. So it's easy for me to see your final answer there. Okay, now for inequalities. So any solution to this inequality is going to be any coordinate that falls in the shaded region. So there's a bunch of different possible answers, but for example, I could say that one right there, which is negative 6, 3. There's actually, obviously there's a ton of right answers, but here's one example. Okay. And then, of course, if it's not a solution, it's not in the shaded region. So that could be anything in this white space. So for example, 6, 5. But again, there's lots of possible right answers. So to graph this single inequality, we're going to start with our B, with our beginning point at negative 2. And then we're going to use the slope, which is 3 over 1, to get our next. So up 3 over 1, up 3 over 1. I'm connecting it with a solid line because there's an equal to sign underneath it. And I'm going to use 0, 0 and see if I substitute 0, 0 into this equation, does it balance out? So 0, 3 times 0 is 0, minus 2 is negative 2. Since 0 is in fact greater than negative 2, that means that 0, 0 is a solution, which means this whole side of the graph is a solution. So that's where I need to shade. Alrighty, so I'm going to graph the one that's in slope-intercept form first. So I'm going to start at the positive 3, and then I'm going to go up 2 over 1. I don't have room to go up 2 and over 1 again, so I'm going to go back here and then go down and over. And I'm going to connect it with a solid line because there is an equal to sign. And then I'm going to go ahead and convert the other one into slope-intercept form. So I'm going to move the 3x over. And then there's a negative 1 in front of there, so I'm going to divide everything by negative 1. So y, this becomes a positive 3x plus 2. And remember that because I divided by a negative number, I've got to flip that inequality symbol around. So I'm going to start at my y-intercept of 2. And then the slope is up 3 over 1. And I'm going to fully admit, guys, I kind of dropped the ball with this question because it's going to be a little bit hard to see the shading because these are a little too close together. So there's no equal to sign under here. So I'm going to make this a dotted line. So, yeah, I did a really crappy job with this one. Let me talk about the shading, guys. So, for the first inequality that I graphed, since y is greater than the line, I need to shade above. So it needs to be shaded like that. And then for this one, since y is less than, I need to shade this direction. And the reason this is kind of a crappy example is because these are like pretty close together. There's actually like a tiny section where they're gonna overlap like right here. So this one's, I did not do a good job with this. I'm gonna have to own this one for sure. But I gave you lots of extra practice problems that are a lot better than this one crappy example I gave you. So please take a look at those extra practice problems to make sure that you're actually looking at some good ones.